Hi everyone, welcome back to chemistry. In this video, we're just going to do a really quick video about molar mass. So what is molar mass? Well, molar mass is just a quantity that shows the number of grams in 1 mole of some element. The number of grams in 1 mole of some element. Okay, and that quantity, molar mass, equals the atomic mass of whatever element you have. So what's the atomic mass? That's given by this number here. Whoops, this number. Remember, that's called your atomic mass number. And that's always found under your element symbol on the periodic table. So for instance, sodium has an atomic mass number of 22.99. At least on my periodic table, there's going to be some differing, some variance in depending on what periodic table you have, because those numbers are rounded. But the one that we have is 22.99 there. And that means that 1 mole of sodium, Na, has a mass of 22.99 grams. Okay, so there are 22.99 grams in a mole of sodium. Okay. So, the molar mass is the mass of 1 mole of an element. And the atomic mass expressed in grams. So again, here's your atomic mass numbers on the bottom there. And those give you the molar mass. Whoops, sorry. So 1 mole of carbon is equal to 12.01 grams of carbon. Okay? 1 mole of carbon is 12.01 grams of carbon. 1 mole of lithium is 6.941 grams of lithium. Okay? So you get that molar mass by looking at the periodic table. These are not numbers you would ever memorize, right? Or that I would expect you to memorize. You actually might memorize some of them just as you keep working with them. Like I remember carbons just because I've worked with it so many times, but it's not something you're expected to memorize, okay? You would always have a periodic table to look at and say, oh, okay, that's the molar mass. All right, so again, looking at the periodic table, just some examples. We've got, sulfur over here, atomic number 16, with an atomic mass number of 32.07. So that means 1 mole of sulfur atoms has a mass of 32.07 grams. Okay, so molar mass, 32.07 grams for sulfur. What's the molar mass for carbon? Yeah, 12.01 grams. What's the molar mass for silver? Yeah, 107.9 grams. Yeah. And you can use, this is just another tool that we can use in chemistry to kind of quantify what we have in lab. So say we have measured out some 12.01 grams of carbon atoms. We can use conversion factors to convert to moles of carbon atoms. And then we can use another conversion factor to get to atoms if we wanted to, okay? And vice versa. You can go the other way as well. So here are just like 1 mole quantities of substances, just so you can get a sense of what a mole looks like for each of these different substances. And notice that a mole of sulfur looks very different than a mole of potassium dichromate. Okay, 1 mole of potassium dichromate is a lot more. Why is that? Well, because your molar mass for potassium dichromate is a lot larger than for sulfur. Okay, so how do we actually calculate the molar mass? So if you have just 1 mole of some elements, say like sodium, like we talked about at the beginning of the video, it can be a little bit easier to find the molar mass because you're just looking at that atomic mass number on the periodic table and you're saying, okay, the atomic mass number for sodium is 22.99, so I must have, 22.99 is my molar mass, right? But it gets a little bit more complicated when you have compounds and you're trying to determine the molar mass of an entire compound. So in order to determine the molar mass of an entire compound, you have to get the molar mass of each element. And you also have to make sure that you account for the number of atoms of each of those elements. Okay, so let's try this out. Okay, so when I approach finding the molar mass for different compounds, I like to break it up kind of like I do in balancing equations, where I first list what different types of elements or atoms I have. So I have lithium atoms, I have carbon atoms, and I have oxygen atoms. And then I just draw a little dash just because I'm going to be doing some calculations. Whoops. Okay, so for lithium, remember when we look at these subscripts, they tell you how many of each type of atom you have. And we can also think of it as how many moles of that atom we have, right? We just learned that in the last video. So how many moles of lithium do I have in my lithium carbonate? I should say in 1 mole of lithium carbonate. Yeah, in 1 mole of lithium carbonate, there are 2 moles of lithium. How many moles of carbon in my lithium carbonate? 1 mole of lithium carbonate. Yeah, just 1, right? What about oxygen? Yeah, 3. So you can think of this in 2 ways. You could think, okay, I have 2 moles of lithium per every 1 mole of lithium carbonate, or I have 2 atoms of lithium in my lithium carbonate compound. They mean the same thing, right? Or I guess I should say you get the same number, right? Okay, so let's take a look up at lithium first. So lithium, we just looked at that, right? Lithium has an atomic mass number of 6.941, which means that for every mole of lithium, we have 6.941 grams of lithium. Okay, in 1 mole of lithium, there are 6.941 grams of lithium. So let's go back down here. Do I have 1 mole of lithium? No, I've got 2. I've got 2 here. So I need, whoops, sorry. Where are we? So I need to account for that other mole of lithium that I have. But I only know the atomic mass number for 1 mole of lithium. But that's okay, so I can multiply. So I have 2 moles of lithium, and for every one of those moles, my mass number, or the amount of grams I have in that 1 mole, is 6.941. 6.941 grams, okay, of lithium. Do you see how I got that number? Let's try it with carbon. So with carbon, we only have 1 mole of carbon. So let's go find what is carbon's atomic mass number on the periodic table. So I'm going to find carbon. Awesome, they've got it right here for me. And I'm going to look at the bottom number, and it's 12.01. So for 1 mole of carbon atoms, I have a mass of 12.01 grams of carbon. So let's go back over here. 1 mole times 12.01 grams. All right, now for oxygen. Again, we're going to have to multiply. So for 1 mole of oxygen, I'm looking at my periodic table and I'm seeing 15.99 grams. 15.99, actually 999 grams. So let's summarize a little bit here. So 1 mole of oxygen has 15.999 grams of oxygen, but I have 3 moles of oxygen, or I have 3 oxygen atoms. So I have to account for those 3. Okay, so I'm going to do these calculations, and then we're gonna, what do you think? Yeah, we're gonna add them all up, okay? So, let's see, we've got, let's do some math here. We've got 2 times 6.941 grams. Whoops, 2 times 6. That is 13.882 grams. And then I've got, this is just going to be 12.01 grams. And then we have 3 times 15.999. That's 47.997 grams. All right, so let's add all those together. And actually, I'm just going to put my adding sign over here on this side. So we've got 13.882 plus 12.01 plus 47.997, and that equals altogether 73.889 grams. All right, but when we represent this number, we actually like to say grams per mole. That's the units for molar mass, okay? And that means that for every 1 mole of lithium carbonate, I have 73.889 grams of lithium carbonate. So let's write that down. So Li2CO3. All right, let's try this next example. So we've got C2H6O. So we want the molar mass of C2H6O. So the first thing I'm going to do is I'm going to list what I have. So I have carbon atoms, I have H's, and I have O's. All right, so how many carbon atoms? I have 2. For hydrogen, I have 6, and for oxygen, I have 1. Okay, so now carbon. What is carbon's atomic mass number? Look on the periodic table. What is it? Yeah, it's 12.01 grams. Okay, grams per mole. What about hydrogen? Yeah, it's 1.008 grams per mole, right? For every 1 mole of hydrogen, we have 1.008 grams of it, okay? All right, what's my molar mass for oxygen? Yeah, 15.999 grams per mole. Okay, so now we gotta do some math. So we have 2 times 12.01. It's gonna be around 24.02 grams per mole. Now 6 atoms of hydrogen, 6 moles of hydrogen, each of those moles has 1.008 grams. So we better multiply. So 6 times 1.008 equals 6.048 grams per mole. All right, 1 mole of oxygen is just 15.999 grams per mole of oxygen. Okay, are we done? No, we wanted the molar mass of this entire thing. So we got to add all those up, right? That's all of the individual molar masses that we have in here, but we got to add them up. So let's go and add them up. So we got 24.02 plus 6.048 plus 15.999 equals 46.067 grams per mole of what? C2H6O. Final answer. I'm confident. Let's see. Did we get it right? 46.08, yeah. Let's see. Was that right? Oh, a little bit off. And the only reason for that is right because I'm probably using some different values for these. Yeah, so they just rounded to 16 and 1.01 for those atomic mass numbers. So that's why they got a little bit of a different number, but it's around the same thing. So all good. Okay. And let's see, their units here are just grams. Why? The only reason that they're just grams there is because they're showing that they have 1 mole of their C2H6O. Okay, so they're just showing the equality. But if you were just writing the molar mass for C2H6O molar mass, you would write it like this: 46.08 grams per mole. Those are the units, okay, for molar mass. And then I did just want to mention one more thing before I go. Remember that you can use these molar masses as conversion factors, right? So you could also, depending on what you're looking for, you could also write 1 mole of carbon on the top and 12.01 grams of carbon on the bottom. Okay, you can use those as conversion factors. You could even use something like this, which we just calculated. Where is it? Oh, sorry, I'm making you dizzy. You could even use this number that we just calculated here as a conversion factor. And how would you do that? You would say 46.067 grams of C2H6O is in 1 mole of C2H6O, or 1 mole can be on the top and 46.067 grams C2H6O can be on the bottom. Okay, so again, you can make them into conversion factors to solve equations or solve other problems. All right, so that's it for this video. I hope you have a good rest of your day, and I'll talk to you later.